THC, also known as tetrahydrocannabinol, is the psychoactive compound found in cannabis sativa. It is made and stored inside tiny crystal-like glands called trichomes, especially on the flowers of female cannabis plants. THC starts out as THCA, a non-psychoactive acid, but when it's heated, like cooking or smoking, it turns into THC. Normally, your body uses its own natural ligands, endocannabinoids like anandamide, AEA, and 2-AG. These molecules are released on demand by postsynaptic neurons. They travel backwards across the synapse to presynaptic neurons. This is called retrograde signaling, and it helps fine-tune neurotransmitter release. Endocannabinoids use synaptic signaling. This is a form of short-distance cell-to-cell communication where a neuron releases a ligand that only affects its close neighbor. THC enters the system and acts like an imposter ligand. THC binds to cannabinoid receptors, specifically CB1 in the brain and CB2 in immune cells. Both are G-protein coupled receptors, or GPCRs. GPCRs span the membrane and activate G-proteins on the inside of the cell when a ligand binds. This sets off an entire chain reaction inside of the cell. When THC binds to CB1, the receptor changes shape. This activates the GI/O G-protein, which splits into two parts, the alpha subunit and the beta-Y subunit. These molecules then move through a cell to change its behavior. This sets off a signal transduction cascade. Number 1, the alpha GI subunit inhibits the adenylyl cyclase, lowering levels of the second messenger CAMP. Number 2, low CAMP means less pKa activity, so proteins don't get phosphorylated as they normally would. Number 3, the beta-Y subunit closes voltage-gated calcium channels, reducing calcium entry. Number 4, it also opens potassium channels, hyperpolarizing the neuron. Normally, endocannabinoids create brief, precisely controlled changes in neurotransmitter release, but THC overrides the system. It latches onto CB1 receptors much longer and in higher amounts than natural ligands. This causes a prolonged suppression of neurotransmitter release, especially glutamate and GABA. Because neurotransmitter release is altered, entire brain circuits behave differently. In the hippocampus, reduced glutamate and GABA signaling disrupt short-term memory. In the prefrontal cortex, decision-making and attention suffer. In the basal ganglia and in the cerebellum, coordination becomes impaired. In the amygdala, signaling changes can create anxiety or paranoia. This is why THC affects memory, reaction time, focus, and mood. And in the cerebellum, coordination becomes impaired. In the amygdala, signaling changes can create anxiety or paranoia. This is why THC affects memory, reaction time, focus, and mood. Thank you for learning about THC or tetrahydrocannabinol. Thank you.